Hello. All right. All right, everyone. Thank you for coming to the bonus math colloquium this week. We are very lucky to have Karel Janeček here, who's has there's many interesting things to say. He was a professional gambler, and luckily he got kicked out of all the casinos in Europe. So he came here to do a math finance PhD. So, and then went back and was a professional, in professional financier, and is now in politics and philanthropy and social causes, and is luckily back for a number of events this week. But we're very, very happy to have him present a math colloquium today. So thank you.
Thank you. Good afternoon, ladies and gentlemen. Let me thank CMU for this great honor that I have be able to speak at Park lecture yesterday, and also thanks to the math department to be able to talk to you about this to me very interesting and funny and perhaps philosophical topic about numbers, about some philosophy behind. As you can see from the label, it's already quite challenging. And let me say that I have devised this talk to be able to perhaps persuade even the skeptics, as I used to be, like still during my senior years, 21 years ago when I graduated, I was still a big skeptic. I would believe that all that we were created randomly. This is the argument that regardless of experiment, unlikely, but if we have infinite many of trials, anything will happen. But then my view of the world started to change. And I came from what I call narrow rationality. Yeah, let me not precisely, but explain what I mean by narrow rationality. Narrow rationality is when it's a scientific rationality, when we are totally rational, when we believe in causality, when we believe that things are random. Like, for example, if I would go to casinos and play blackjack, I assume as absolutely given that the cards are random. And if anybody would tell me that you can follow some factors and you can change your betting based on how much you won or lost or something like that, I would know that it just doesn't make sense, that it's a psychological biases that people are subject to. So this cannot work, that the trials are, other than card counting, but in principle independent, that things happen randomly, at least from given the information, the set of information that we have. And this was my strong belief until, when I was 33, 34, I started to observe things that seemed already very suspicious to me. There seemed to be that there are things happening in some synchronicities, which would be beyond the randomness, beyond explicit causality, beyond mainstream physics. And I started to observe that, and because my education is theory of probability and statistics, I started to devise some kind of test for myself, and I would observe, and it was totally shocking for me, then the things that I could see were disproving total, let's say, randomness from this point of view. Things did happen in some synchronicities, and for me, this was a shock, because it was a total breakup of my paradigm of what I believe. Nevertheless, it did happen, and because proofs are proofs, I could not dismiss them. I started to accept a little bit, perhaps different reality, and from that, it logically followed that I was thinking about numbers. Perhaps there could be another meaning, especially for integer numbers. Many people think so, they will think so in the past. And when I came to this observation, I started to initiate some research into that myself. So I moved from narrow rationality, the scientific rationality, which is very important and very good and necessary for what we do. I moved further. And the first step, I call it now extended rationality, which is rational thinking, but conditional on that perhaps what we can see, observe in mainstream physics might not be, is probably not everything, and there are things that really are beyond this standard just causality logic. So thinking about numbers, because I always love numbers, It's also from blackjack. It is, you know, blackjack is about 21. We will get 21 is stands out there. So when I started to explore a little bit more, the first number that came as very interesting, of course, number 1, number 0, but number 1, number 2, but from a little bit larger number. What started to shine out is number 12. And we have that dodecahedron, like one of the 5 Platonic solids in 3D. According to Plato, 12 would represent ether and things like that. So that was the number that I came to, and I could observe many interesting combinations, which seemed to be beyond pure chance. As I kept exploring, things started to move, and more was pointing towards number 21. So 21 started to be the very special number. In fact, I would always argue that the pair of numbers 12 and 21 is something very unique. I am saying this story for you to see that all that will follow is actually not a backward deduction, that it is something that is going out of these observations strictly. No statistical cheating that I am doing or I was doing in my life. So to me, 21 started to be a special number. I will not argue here why. I had many arguments. In fact, in 2016, I was giving the talk at one big festival, Colors of Ostrava in the Czech Republic, to many people. And I dare to publicly say that 21 is the number of our universe. Of course, it's maybe a bit of a joke, but I did explicitly put this in the space together with number 12 as being very special. Now, one of the reasons we could argue that, you know, the ultimate question of life, the universe and everything, we don't know the question, we know the answer, right? My argument, my point only is that the deep thought after 7.5 million years made a small error. It divided or multiplied the result by 2. So the answer should be 42 by 2, perhaps. So this is what I'm going to argue now. Now, with all this fixed, 12 and 21, in my talks, in my games, actually, maybe there is one thing that I will tell you. I was successful not only in blackjack, but later also in financial markets. And with my success, I started to devote my attention to society, to people, what was happening, trying to fix things. In order to fix things, I started anti-corruption endowment and things like that. Those are other stories, but important consequence is that I have several endowments, and these endowments give prizes, for example, to people. And when I found out about 1221, I decided, okay, why not? Why using rounding numbers? Why should I give a prize of 200,000 Czech crowns? I can give a prize in the power of 12 to the 5th power, right? Or I can give 21,000, not 20,000, things like that. So I started to play these games out of fun because there is no downside. Perhaps there might be upside. I even go further that when I have meetings with people, business meetings, I put the meeting at 12:21 or 15:21 or things like that, which might be a little bit annoying for somebody, but nevertheless, it has very good consequences, by the way. It is a great marketing tool. I realized later it was not my intention, but I realized that when giving prices and using numbers like that, people get caught by attention. And also it has an interesting educational effect, because when you see a formula, not you, but when some people see a formula 12 to the 5th power, they have to think what it really means. So it refreshes their mathematical knowledge. So these games I would play since 2014. The rules are clear. So why I'm saying it, for you to see that what we will see further is just the no statistical cheating. Anyway, Sheldon theorem. Who knows? Do you know what Sheldon theorem is? I will show you in a moment. It's a very interesting theorem, which I learned about, I think, in the year 2019. And for me, this was, wow, this is so amazing. Remember, at that time, I had 21 as the number of our universe in connection with 12. So, and then I found out Sheldon theorem, which says that 21 is the only number in decimal system which has this interesting property that is not reverse, how do you say? Reversal, okay, is reversal 12 in connection with 12, which is the current 1221, has such a properties that 12th prime number is 37, and 21st prime number is the reverse 73, and also 7 times 3 is 21. And Sheldon's theorem, that's in the pigment theory, that's where I saw it, and I'm so sure to see it. Sheldon's theorem says that 21 is the only number in decimal system. It was proven, I think, like 2 years ago with huge computer calculations, because it is not hard to prove it for numbers less than 10 to the 40th power. And all the other numbers were calculated smartly. So anyway, it was proved using completely computing power. It is by no means something given. I know that, for example, in a system of 9, there is a solution of this, which is like a huge number of how I don't know how many digits. So anyway, 1221 has this beautiful property, which for me was out of sample. And that made me to confirm the fact that 21 is what I was saying. Aesthetics of numbers. I told you already how I use the aesthetics of numbers upfront before. So obviously, the next thing, using now this new observation about Sheldon's theorem, 3773, how will aesthetic number look like? So for 4-digit numbers, for example, it will be 1221, 2112, 3773, 7337, 1732, right? You have the 73 and 12, so there is the Sheldon kind of conjecture, or Sheldon theorem is kind of encoded in these aesthetics number, etc. So we have these 4-digit numbers. What else? As I told you, 12 to the third power, 21 to the third power, 37 times 73, etc. Those are aesthetic numbers. What would be 3-digit aesthetic numbers? Well, obviously, 12 squared, 21 squared, 12 times 21, 777444, right? 271, 127, 271, why these? Well, we have, from the Sheldon theorem, we have 1, 2, 3, and 7. If it's a 3-digit number, we need to drop 1. Which one will be dropped? We will drop 3. If you think about it a little bit, you drop 3 because you lose least of the aesthetics there. Why? Because 3 is encoded in the 1 to 7. And it is in the best way encoded in 271. You can see it is encoded there because it's 3-digit, because 3 is 2 plus 1. It is 21 divided by 7. 2 plus 7 is 3 squared. 27 is 3 cubed. So it's very nicely the 3 is hidden there. So we got from this aesthetic approach, a direct aesthetic approach, we got number 271. We will get to back. This is the most important number in the end, we will see. Is it art or coincidence? Remember, I had encoded 12 and 21, found Sheldon's theorem, which for me was like, wow. And now I go further with the same strategy, no trials and errors. I'm not going to have a huge sample space trying to find a different combination. This is all direct approach. This is not that I would try 100 or 1,000 or whatever number of cases and then find something interesting. This is a step-by-step direct approach. So obviously, the combinations, multiplication, 12 times 37 should be a normal number, right? Well, but it is 444. That's one of the most aesthetic numbers. What about 12 times 73? 876. Again, very beautiful number. Sum of digits 21. What about 37 times 21? The most aesthetic number, number one, 777. 3 times 721. So is this a coincidence? These properties, I don't see any any relationship, anything that something would imply another one or something like that. And if you look at it, for 3-digit numbers, we have 900 numbers. 777 is the, let's say, most aesthetic one. But even if we take, there could be 10 of them like that, if there could be even a little bit more, we have the probabilities of all this happening 1/102 cubed, at least in this order, 1 in million. Yeah. Again, no many trials, direct approach. So this is really the calculation what we can argue. So amazing coincidence, perhaps, but it's already extremely suspicious, right? Because we are already out of sample of 12 or 21 being fixed. All these following directly, not through searching and backward discovering. Now, a question for you, for mathematicians. First question doesn't make much sense. What is the most important irrational number? Well, this doesn't make sense. But what makes sense? What common irrational number would two theoretical mathematicians choose if, in order to choose the same number, because they get the prize, they choose the same number, right? A theoretical physicians. What number would you choose? That should say theoretical mathematicians, physicians, right? Because pi is of scholar. That's the second candidate. But I believe who would have another choice than pi? Yes, E, Euler's number, right? So, and I would argue that the E is number one. Obviously, pi is also very close, right? So even if we took E and pi both. So then again, what is E, right? E is 271. So the probability here is, again, in the order of perhaps 1/500 if you take pi as well. But it is, again, very small. So it's another 2 orders chance. So another question for you. And it also, it relates to the approach I have designed the aesthetics numbers. There is nothing changing, no trials, all direct step by step. What is the simplest non-trivial operation? Well, this is, again, not a rigorous question. But I showed you, right? There was if there are 2 interesting numbers, 21, 12, I multiply. I do 21 squared, 21 cubed, etc. So what is the non-trivial operation? It's for one number. If you have one number, what is the operation? What would you guess? If you have one number, you want to do something that's not trivial. You don't see a result immediately, but it is simple. What would you guess? Square. Square, yes. Oh, that's the number one, what we choose. So what is 271 squared? 7,321 squared. So this 73441, of course, there are more that first order, let's say, most interesting numbers like that. It's more of them. Probably in the order of 12, maybe 21, but certainly the upper bound is the answer to the question of universe. So it is less than 42, right? So, and we have 5-digit numbers is 90,000. So again, we are safely probability less than 2100. Okay, so again, more than 2 orders probabilities. We are continuing with these probabilities. And we are still not over, by the way. The most interesting is coming. And for the most interesting exposition, I will ask you if you know what are Tesla's numbers, Nikola Tesla's numbers, not the car. Do you know Nikola Tesla was actually obsessed with numbers? Some people say that I'm obsessed with numbers. Okay, but I believe I have it rationally anchored. Tesla, I don't know, he probably did. He was talking about different frequencies and stuff. And do you know what his like most special number was? It was multiples of 3. Yeah, he was 9. It was 3, 6, and 9. He was stressing 9, and the frequencies were 3, 6, 9. If you type in Google Nikola Tesla number, it will jump out as 369, 369. Okay. Okay. So we have 369. Just again, no trials and error, no big sample space. Do you know of any other, let's say, historical child or important person who would be upset with a specific integral number? Is there any? I don't know. I'm sure there might be some, yeah, but certainly Nikola Tesla stands out in the universe. So we are 369. We put this aside for a moment. And now another question. What is the next non-trivial and simplest mathematical operation after square? What would you choose? Square root, yes, that could be one. So here the sample space, we have already square root. There is, I would argue there is one even tiny, perhaps more interesting, but at least in the same order. A cube is like the next power. That's already worse than a square. Of course, the other direction, if you go, yes. We were talking about square. To the power, okay, I told the answer inverse, right? If we have a number, it's inverse. And we are not going out of integers, but inverse is like a very clear, straightforward mathematical operation. Okay, maybe in this sample space, we have already few trials. Okay, we have few more operations, but inverse is like a top one. A question for you. What is the usual length of periods of the inverse of a prime? If we have prime P, how long will be the period of its inverse, usually? In the order of probably P, right? On average, maybe half P or something like that. There are some primes who have lengths of periods P-1 of its inverse. There is so-called Artin's conjecture, which says that about 40% of primes have its inverse have lengths of period P-1. 200, as you can expect, 271 is, again, this something very special here for its inverse. When I did it, of course, I typed 271 squared. I was like, wow, this is amazing. The next thing I tried was 271 inverse. What I found was, wow, this is so amazing because 271 is exceptional. It has extremely short period. Its period length is only 5. It is, in some sense, if you take there could be argued that this is like, in a certain sense, the shortest period for a set of primes or something like that. This is, again, not rigorous statement, but nevertheless, the period is extremely short for a prime like 271. There is, yes, a period of a prime 101 is also short, but that's special because if we switch ones, 0 ones, we are getting, but anyway. So 271 has a very short period and very nice period. And when I tried it, I was like, this is amazing, but I didn't know about Tesla. And then I was showing this to my friend and I came, okay, look at what the 271 inverse is. You will show him a moment, and he was like totally baffled. And you know, because he was a big fan of Nikola Tesla, which I didn't know. So expected length we talk. So 271 to the power of -1 is 369. 00369. What is the probability of that? I don't know, but it's extremely small. It's many, many digits again. I think it's extremely small. It connecting to Tesla in this way is the consequence. 271 times Tesla numbers is 5 nines. 5 nines are Tesla, right? Tesla is 9, number 9, number 3, 6, 9, and 9. So probability of that happening, I think, is smaller than all the probabilities before which we calculated. And so we are getting to cumulative probabilities of 1 or 2 before we get 1 of hundreds millions or even billions and plus this. So we are in the power, I don't know, 10 to minus something big. Okay. And so to me, thank you so much for your attention. But what is the conclusion here? To me, the conclusion is that this is a statistical proof that we could not exist here as a purely random evolution. Because, yes, anything can happen if you have an unlimited number of trials, like Stephen Hawking's this theory is, yes, there's unlimited number of trials, so anything can happen. Anything can be a result of random evolution. But then we would have to be this extremely random thing in the random evolution for which we have infinitely many trials. But we are one of the trials, one of the specific trials, right? We are not infinite, unlimited number of trials in unlimited number of trials. So this, to me, is statistical proof that when math was created, when rational thinking was created, when numbers could happen somehow in the universe, that we could grasp them. So at that time, at least, there must have been something greater that created this world, at least our rational thinking. So thank you for the attention. I'm open to discussion and comments. And of course, I would like to ask, I will be happy to ask you how you see it. If there is amongst you, if there are people who would be skeptic in that way, because the way I design it is that I believe I would persuade myself 21 years ago. Thank you.